So y is always the same thing with f of x. Same thing. So we can be asked to find f prime of 1, which I prefer as notation. That's our question. Or we may be asked to find the same thing, the derivative of y with respect to x, when x is 1. So as you know, I have to have a function to plug in. I cannot start with this. I have to find this, the derivative, and then plug in 1. So when I look at this function, I will rearrange it, first of all. So x is x, no problem. But if you remember, we studied exponential rules. Is there another way of writing 2 over x cubed? Is there another way of writing 2 over x cubed?
2 over x to the negative third power.
You mean 2 times x to negative 3. Awesome.
2 times x.
Yes, I completely agree. That's Huber, right?
Yes, ma'am.
Okay. You didn't pay your brother to attend, I hope. I'm kidding. Okay, so now the reason why I changed this is because it's much easier to differentiate than this situation. So now we can find either y prime or f prime or dy over dx. They all mean the same thing. Can anyone give us the derivative of x? Okay, Carmen, what is the derivative of x? Thank you. Plus. How do I differentiate this? A constant times x to a power. Joan, would you like to help here?
Can you repeat that again?
Yes, sorry about that. I'm differentiating this. It's okay if you are not sure.
Would it be 6?
Careful. 2 times negative 3.
6.
Yes?
X to the negative 4.
Excellent. So we bring down the power. It's negative 3. We multiply by 2. We get negative 6. And we have to subtract 1 from the power. So then the final simplified form, I would write it like this. Now I can plug in 1. So can anyone tell us what is dy over dx when x is 1? See, this is a cumbersome notation because there is no way I can put parentheses and say f prime of 1, but this is what it means. So can anyone plug in 1 here and give us the result?
The negative 5.
Very good. 1 minus 6 is negative 5. This is it. Again, what does this mean? It means that there is a function, that one, and at this point, when x is 1, the rate of change of the function is a negative number, negative slope. So this slope is negative 5. The rate of change at this point, in other words, the function is decreasing. The slope is negative 5. Awesome. Okay, back to the book. I'd like to look at an application now, and we can choose another equation if you'd like. But I'd like to, what I did, oh, no, I didn't mean to do that. I meant to show you that on the next page, I think, I selected this problem since I didn't mean that. I don't want summary. I just want to move this up. Oh, okay, good. So since we just, I don't want to write anything. I'm not sure what I'm doing. Anyway, so I just wanted to talk about this because we just went through the turmoil of Superman. I'm guessing you all like it. I can't, I don't know what I did. What did I do? What did I, toolbar, I got it. I don't want anything. Just leave me alone. Okay, finally, good. So I'm back. So the price of a ticket to the Super Bowl 2 years after 1967 can be estimated by this function. And I do have it copied already. And here's the rest. So this is the number of years since 1967. And this is the price in dollars. And here's the function up here. Then we have to answer 3 questions. Use the function to predict. It doesn't say to evaluate. So I don't have to plug in the function anything. It just says to predict the price. So actually, I'm taking that back because it says the function. It doesn't say the graph. So I have to use the function. So use the function to predict the price of a Super Bowl ticket in 2020. So 0 represents 1967 because it says 0 years, number of years after 1967. So right here, this point is 1967. 10 years later, 77, 87, 97, 2007, 2017. So they're asking us to use the function to predict the price of a Super Bowl ticket in 2020. Okay, what do I have to do? Because it says the function. I can read it and I can estimate it from the graph. But they are saying to use the function. What do I have to do if I'm asked to use the function? And I'm going to copy the function here. So that was, what problem was it? It was 95. 95 and the page 156. And here it is. P of t, price function of time, 0.858 t squared minus 18.864 t and plus 78.354. At that time, they didn't know that the tickets may get to $100,000, I heard. Okay, so let's assume that the model is still valid, or was. How do I use the function to predict the price of a Super Bowl ticket in 2020? Any suggestions?
Do you substitute t for 2020?
Careful. So t, very good. So t is the number of years after 1967. So 1967 represents t equals 0. What will 2020 represent? What t will that be?
53.
Say it again.
50.
So you are saying 53? Did you say 53 or 50?
50.
So 20 plus 33. You mean 53 years, right?
Yes, 53.
Excellent. Very good. So let's plug it in. You know me, I refuse to do this by hand. So I'm going to share my screen. And I'm going to go to the calculator. I'm going to put in my function. And that is 0.858 t squared minus 18.864 t and plus 78.354. Perfect. And now second end table, I plug in 53. It's done. They wish, right? They had no idea. So P of 53, it appeared to be 1,488 since it's US dollars, 0.68. So we determined the price in 2020 according to this formula. Fine, that is done. Part A is clear. Find the rate of change of the ticket price with respect to the year. In other words, dp over dt means p is a function of t. Find its derivative. So this is a key sentence. That's why I started with this tonight. If I'm asked to find the rate of change of a function, I'm really asked to find f prime. Or if you want, dy over dx, same thing. Or y prime, all the same thing. Good. So I have the function. Can anyone help in finding its derivative? And you can say it's hard because you have to multiply those numbers. That's fine too. So p prime of t. I bring down 2 and I multiply. 1 and 1, and this is 16, 17. T. So 2 times 0.858. So please correct me if I'm wrong. Always make sure that my numbers are correct. Minus 18.864. This is it. This is the rate of change. And that reminds me of something that I noticed on your last homework that I graded. And please, 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 please. Rate of change has 2 measurement units. You will always miss a very easy point or two if you do not state the measurement unit. Every time, not here because we didn't calculate anything, but if we're asked to find something and it's a rate of change, the value of a rate of change, and we have P in dollars and T in years, you cannot just say it's dollars. You cannot just leave it alone. You have to write dollars per year. The measurement unit of this will be in dollars per year. The measurement unit of this will always be in dollars. It's price. But this is the rate of change, which means dollars per year. Okay, so now we determine the rate of change. What is the rate of change of this function? 1.716t minus 18.864. Final question. At what rate will ticket prices be changing in 2020? What is this question all about? What are we asked to find now? Please help. Anyone, please. It's okay if you're wrong.
Oh, are we doing y2 minus y1 over x2 minus x1?
Not anymore, because we already have the function. Actually, it's a very good point. Confusing. So let's talk about that. We have average rate of change. We have instantaneous rate of change. We have rate of change. Which one? What am I doing? What am I applying? Okay, the average rate of change requires 2 points. I cannot determine the average rate of change if I don't have 2 points. This is not the discussion here. The instantaneous rate of change and the rate of change are the same. So we are asked to find the rate of change. We did. Then we are asked at what rate is the price changing in 2020. So what am I asked to find now? Here I was asked to predict the price. But here I'm asked to, what is the rate at which it is changing, the price it's changing in 2020? What am I asked to find now? Anyone, please.
Is it the difference in cost between 2020 and 1967?
Very
Or
good.
difference in price?
Very good question. Very good question.
Is it the rate as in like how fast it is, like every per year?
Yes. So what am I asked to find? What am I asked to find? In 2020.
Prime again?
Exactly. F prime for 2020. Exactly. That's exactly what I'm asked to find. So this is P prime of 53. So in the previous question, I was asked to find P of 53. Then I was asked to find the function that gives the rate of change. Now I'm asked to evaluate the function that gives the rate of change 53 years since 1967. Do you understand the difference between these three? Should I repeat the difference between these three questions?
Yes, please.
This one says, plug in the function and give the price. This one says, find the function that gives the instantaneous rate of change. This one says, evaluate the function that gives the instantaneous rate of change. Should I repeat that?
Yes, please.
This one says, evaluate the function at 53. This one says, find the function that gives the rate of change. This one says, evaluate this function at 53 to see how fast it's changing, not the value. This function gives the value. This one gives the rate of change. And this one gives the rate of change exactly at 53. Value of the function, the rate of change, the value of the rate of change. So part C is nothing else but P prime of 53. And P prime of 53, go back to my calculator. I put in the second function. I may need the first one, who knows what, for whatever reason. So I'm not going to erase that. 716 t minus 18.864. And I don't have to plug in anything because it's already there. So at 53, the value was this. And in other words, in 2020, the value was this. And in 2020, the price was going up per year by $72. So the answer is 72.08. And since it's a rate of change, I cannot have only a measurement unit. I have to have two measurement units. So it's going up every year by 72.08 in 2020, moving forward. Good. Okay. Any questions for me? So I think I can put this in the recycling bin. I think so. Now, okay. I'd like to continue with two other rules.